Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 9007000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. So I'm going to start just by writing out the equation. And I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now, to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says to expand your answer fully, so we're just going to expand the brackets. 7m plus 70. So to simplify 10 to 22 to 26, I'm going to have to find something that I can divide the 10, the 22 and the 26 by. The biggest number I can do that for is 2. So if you look, 10 can be divided by 5, but nothing else can. 22 can be divided by 11, but nothing else can. And 26 by 13, but nothing else can. The only thing we can divide all of them by is 2. So that will be 5 to 11 to 13. So the answer is 5 to 11 to 13. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h, and a and b are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half a plus b h. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So we know that James knows that he has a square, so we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. To find the largest weight this package could have been before it was rounded, let's do a quick number line. And we're going to just do it between the 24 and what it would round to next. Well, it's to the nearest kilogram, so the next thing it would round to is 25. The cutoff point for rounding is here. And that's going to be halfway between 24 and 25, which is 24.5. And that is actually going to be our answer. Now, some of you who are astute might realise that 24.5 would round to 25, but theoretically the biggest it can be is going to be 24.49 recurring. Let's just draw that a bit better, 24.49 recurring. And that is actually the same as 24.5. In your exam, however, you can write 24.49 recurring and you would get full marks, but for brevity, I would definitely recommend writing 24.5. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. We can keep this as an interior angle, but it's actually sometimes easier to convert it to an exterior angle. And what you might know is that the sum of interior and exterior angles is going to be 180, because they will always form a straight line. So to find the exterior angle, all we need to do is 180 take away the 170, and that means it will be 10 degrees. So we've already done a different formula for exterior angle, which is 360 divided by n. And something we can do is we can just swap these two things around, and so we can make the formula that n equals 360 divided by the exterior angle. So 360 divided by the exterior angle, well, we know that the exterior angle is 10, therefore n is 360 divided by 10, which would be 36. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17. And we put that over the amount in total, so over 54. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything, or we could just write y equals 9x. I'm going to say plus 5. The formula for the volume of a cylinder is pi r squared h, with h being the height. So we've got pi times the radius 11 squared times the height. That gives us 7,602.654 blah blah blah, and to two decimal places that is 7,602.65. I'm going to write this out just a bit bigger so we can see what's going on. And there are loads of different methods for expanding brackets. I'm going to use smile and rainbows. So smile there, rainbow there, and I always put a little notch here to remind me to times it. So we're going to do 4 times 8, which is 32. And x times x, which is x squared. Then we're going to do 4 times 3, which is 12, and x is just there. So when we expand that, we get 32x squared plus 12x. So to find our new triangle coordinates, what we're going to do is we're going to have a look and see what we have to do to get from the centre of enlargement to each of the corners of A, or the vertices of A. So to get from the centre of enlargement to this coordinate, we go left 2, but it says scale factor 3, so instead of going left 2, scale factor 3 would be 2 times 3, it's going to go left 6, so 2, 3, 4, 5, 6. So the new coordinate for our shape is going to be here. We're going to do the same to the other part, so up 2, 3, 4, and 4 times 3 is going to be 12, so 4, 5, 6, 7, 8, 9, 10, 11, 12. and then we've got to go left 2 to line it up with our coordinate here, and so we'll go left 6. So what, 2, 3, 4, 5, 6. So our new coordinates here. The bottom right one's just going to be a shared one because it doesn't go anywhere. So we draw in our new shape. And there we go. And it says to label it B, so I'll put a B in it. Factorising is the opposite of expanding. With expanding, we're multiplying out a bracket. With factorising, we're putting something in a bracket. So I'm going to start by just putting the bracket down. Now I need to ask myself, what number can I divide out of 3x squared and 5x? Well, there's not going to be a number I can divide out, but they both have at least an x. X squared obviously is x times x, and x is just on its own for the 5x. So we're going to divide out the x. So I need to ask myself, what times x is going to be 3x squared? Well, obviously 3x. And then we ask ourselves, what times x is 5x? Well, that's just going to be 5. And if you were to expand that set of brackets, you will get 3x squared plus 5x. So we know it's the correct one. And so our answer will be x brackets 3x plus 5. So we know that the exterior angle is equal to 360 divided by the amount of sides, which we can just call n. And something you can do is actually just swap these two things around. And we can say that the n, the amount of sides, is 360 divided by the exterior angle for a regular polygon. So we just do 360 divided by 5, and that gives us 72. The formula for the circumference of a circle is circumference equals pi times the diameter. In this question, we're given the fact that the circumference is 37.7, and we're asked to find the diameter. So if we put our lines in, all we need to do is divide both sides by pi. So we've got 37.7 divided by pi equals the diameter. And so that is, when you round, well, it's 12.00 blah blah blah. Round to the nearest integer, that would be 12 centimeters. And we can try it by typing in 12 times pi, and we get what would round to 37.7. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. First thing we need to do is work out the volume of this prism, and it's a trapezium based prism. So the volume will be the area of the cross section or area of the trapezium times the length, how 3D the prism is. So trapezium is half a plus b h and then times the length. Now A and B are the two parallel sides, which will be this one and this one, and then the H is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything for this will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. The arc is a section of the circumference, and I'll show it on the diagram here. This is the arc. And to find the length of the arc, we use a simple formula, and I'm just going to explain what the formula does. So the arc length is equal to the fraction of the circle that you've got, and we times that by the circumference of the circle. Now, to find the fraction of the circle we've got, we work out the angle of the sector and we divide it by 360, because there are 360 degrees in a full circle. Times that by the circumference, and circumference is just going to be pi times the diameter. The angle is 61 degrees. Now the diameter, if you imagine that the circle is all the way around, so it's a full circle, you can see the 6 centimeters here is the radius. So if we carry that on, there'll be another 6 centimeters here, so the diameter will be 12. Just 2 lots of the radius. Type that into a calculator and we get 6.387, blah blah blah. And it says it wants it to 2 decimal places, so when we round that it comes to 6.39. So I'm just going to write this out again, just so we've got a bit more space. Okay, the way we solve this is very similar to solving an equation with equal signs, but this time we're going to do 2 tramlines because there's 3 sides of this inequality, and we need to get x on its own. So looking at the fact that we've got 3x minus 5, we're going to deal with that minus 5 first. So we're going to add 5 to all 3 sides. So add 5 here. So we'll just leave 3x in the middle and add 5 to the right hand side. Now we need to get rid of that 3, so we're going to divide by 3, and again we need to do it all 3 sides. So divide by 3 and divide by 3. So we've got x is greater than or equal to 7, and then we've got 10 is greater than x on the right hand side. So this question is a simultaneous equations question, And so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears costs £7.80. or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24, so I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8, so that this becomes 24. So it's going to become 8A. And so we're going to times the 2A by 8, which will be 16a plus 24p, and 380 times 8 is 3040. And we're going to do the same with b, but this time we're going to times it by 3, so we're going to have 3b. And we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted. And 780 times 3 is 2,340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now, if they are the same, the S in same is the S in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the D in different is the D in add. So here they are the same, so we are going to subtract. And we're going to subtract going downwards. So we're going to start off by doing, and I can just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a. 24p take away 24p, which is nothing, which is why we did that. It's to eliminate them. And then 3040 take away 2340 will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get A equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write it out. But instead of A, we know that A is £1, or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down. And we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So that's going to be 780. So we know that we've got it right. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100. So that would be 65%. I'm going to start by just drawing the line y equals minus 2. So the line y equals minus 2 will be a horizontal line at minus 2, which will be down here. Next we're going to do the line x equals minus 1, and that will be a vertical line at minus 1. Now here's a bit of a problem. We've got no equal to underneath it, and whenever we don't have an equal to, we do a dash line. So we're going to do a dash line here. Okay, the last graph is a little bit harder. We've got y is, or I'm going to do y equals x minus 3. And it's going to be a perfectly diagonal line, but down to minus 3. So it's going to be this line here, about there. But it's going to be dashed because we don't have an equal to. So it's going to be a dashed line like that. So if they have an equal to underneath, then it will be a solid line. If they don't have an equal to underneath, it will be a dashed line. Okay, now we've got to work out where the region is. So we've drawn the lines, and the lines are either dashed or solid, and so they're perfect, but we've got to work out where the region is. So we can see on the first one that y is greater than or equal to minus 2. So it's going to be above this line. Okay. You can see on the next one that x is greater than minus 1, so it's going to be this side. So we've already narrowed it down to somewhere in this region here. And here we're given that y is greater than x minus 3. So what we do here is we pick a point. So I'm going to pick a coordinate, and I'm going to pick 0, 0. 0, 0 is always my go-to one. Write out the equation, and I'm just going to put a box here. So x minus 3, and fill in the coordinates for 0, 0. So 0, blank, 0 minus 3, 0, blank, 0 take away 3 is minus 3. So what is 0 compared to minus 3? Well, 0 is greater than minus 3. And therefore, this coordinate is on the correct side, because if we look, we've got y is greater than x minus 3 is our region that we're looking for. So we're looking for that, that's good. And so our region will be anywhere in this bit here. Anywhere at all. And you're asked normally to mark it with an R. I'm kind of colouring it in just because your R can be anywhere within this region. It can actually be at 0, 0. Anywhere within the yellow region would give you the mark. The first thing to notice is we actually have two radii here. So we've got this radius here and this radius here. And all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well. And we've got to write that down. So we're going to say angle OBA is equal to 19x. And the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here. And all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180. And let's get our solving lines in. And we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now, there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, it's just 90 take away the 19x? Well, we know that 19x is 19 times 4, because we know that x is 4, and so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over the cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier, and we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. We're going to start by working out what outcomes will give us two different types of drink. So we could have OA or AO. We could have AW or WA, and we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO. Same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27. And then 12 over 26. And so that would be 108 over 702, and then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together, and when you add them together you get 234 over 702. Now I said we would deal with the reverse situations now. We're going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. Whenever you're asked to work out a proportion of items in a histogram, you can actually do it by just counting the squares. So in the first bar, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 squares here. The next one, you've got kind of 4 half squares, so that will be 2 squares in total. and then we've got 4 squares in the last one. So altogether we have, for the amount of squares, we have 12 plus 2 plus 4, which will be 18. So it's 18 squares in total. Now it says that we're looking for between 25, which will be here, and 45, which will be here. So we count the squares in this little interval. So there are 3 here, and there's half a 1 here. So the squares between 25 and 45, I should say dash 45, 25 to 45 is 3.5. Okay, so we've got 3.5 in total, or 3.5, out of a possible 18. So we just need to do 3.5 divided by 18 to work out the proportion, and that gives us 0.194 blah blah blah. It says it wants its 2 decimal places, that would be 0.19. I'm going to first of all just focus on this rectangle here. And we know that to find the area of a rectangle, you multiply the 2 lengths. And when you've multiplied them for this rectangle, we get 697. But let's write down what A is equal to. And A will be equal to the area, which is 697, divided by the length at the top, which is x plus 30. Now let's focus on the other square, or the other rectangle. And this time we have A equal to the area of it, which is 1870, divided by the 10x. Now because both of these are equal to A, we can actually just get both of these fractions equal to each other. And what we can do is work out what x is going to be. So first thing I'm going to do is I'm going to put my lines in, because we are looking to solve. This is probably going to take a while. And I'm going to times both sides by the x plus 30, so I can get rid of the denominator on the left hand side. And so this will just be 697 on the left hand side, because that gets rid of the denominator. And it will be 1870 times x plus 30, and then all of that over 10x. Same thing again, but I'm going to get rid of the denominator on the right hand side, so I'm going to times both sides by 10x. So we've got 697 times 10, which would be 6,970x, because it's 10x. And it won't actually do anything to the right hand side, but I am going to expand the top, the numerator. It just gets rid of the denominator. So let's expand while I'm here. So that would be 1870x plus, what is it, 56,100. I believe that's right. Yep. Okay, so now we've got x's on both sides. So we look and see which one is the smaller amount of x, which is the 1870, and we're going to take that away from both sides. So take away 1870x from both sides, and that will leave 5100x on the left hand side, and then obviously we've got the 56,100 on the right hand side. And we want to get rid of the 5,100, so we're just going to divide both sides by 5,100. And so we've got x equals 11. So now we know x is 11, we can pick one of the equations that we had at the start, and I'm just going to pick the first one, and we can just feed in the value of x. So a equals 697 over, instead of x, it's going to be 11 plus 30. And when you do that, you get the answer of 17. So A is 17. With this question, we're going to first of all have to find a length before we can find the length AF. And it does involve us thinking in 3D. What I find sometimes useful though is to draw kind of a 2D representation of the 3D. So I'm going to look at this triangle here, and I'm going to notice that I need to find length BF. That's going to be my objective at the start of this. So I'm just going to draw out this triangle again, but in 2D just to make it a bit easier. And BF is this length here, this is 6, and then this is 9. So we're going to use Pythagoras, so it will be sort of a squared plus b squared equals c squared, so it would be 6 squared plus 9 squared equals bf squared. 6 squared plus 9 squared is 117. And then we just get our solving bit in, just to square root both sides. And I can leave this as square root 117 for now. Okay, the actual length that we want is AF, which is this one here. And I'm going to create the right angled triangle using this bit here. So let's just draw that out. Now the top bit is AB, which is the same as the bottom. It's going to be 14. It's going to be the same as EF. Then the BF we've just found is root 117, and we're looking for AF. And this is the right angle. I didn't show the right angle on the other one, but it should be there. Okay, so we're going to use our a squared plus b squared equals c squared. And a squared is 14 squared plus square root of 117 squared equals AF squared. So 14 squared is going to be 196. Now root 117 squared is just going to get rid of the square root, so it's just going to be 117. And when you add them together you get 313. And again get our solving lines in. Square root both sides. And this time we're actually going to square root 313 because we need a decimal answer. So it would be 17.691 blah blah blah. It's equal to AF. And it says to 2 decimal places, so that's going to be 17.69 centimetres. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top. Then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4 and the height is 5. And the radius for the larger cone is 20 and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.975 blah blah blah. We're going to work out the volume for A, and this time it will be 1/3 times pi times the radius now is 4, and the height is 5. So that will be 83.775 blah blah blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah blah blah. And to 2 decimal places, it's going to be 10,388.20. You can complete a unique version of this paper by going to our onmaths site, OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.